Here is a very interesting question to write down equation of a line from the graph in R2. Write the equation of the given lines in different forms. So we have three lines here, L1, L2 and L3. You need to write their equations, line L1 in vector equation of L1, then parametric equation for L2 and scalar equation or Cartesian equation for L3. So this exercise will really help you how to relate graph with the equation. So write down your answer, pause the video and then look into my solution. Now let's see how to write the vector equation of line L1. For vector equation what we need is a point and the direction number. So we can select any point on the line. Let's select this point here on line L1. So coordinates of this point are -4 and 3, right? So we get this point -4 and 3 here plus parameter t with direction number. So what is the direction? So select any other point, let's say this point. If I want to go from here to this place, then 2 steps in positive x direction and 1, 2, 3 steps in negative y direction. So that gives us the direction number and that becomes the equation of my line L1, right? And this is the vector equation of the line. Now let's move on to line 2, which is this line going through the origin. Parametric equation for line 2. Parametric equation is written in the form of x equals to what and y equals to what. So we take a reference point here. We could take 0 as a reference point. So it becomes 0 plus direction number, right? So t times what? So we can consider any point here. So move from origin to that point, we need to move 1 unit to the right and 2 up, right? So it becomes in a way 1 unit to the right, so t times 1. So you get t here. Let me write first 1. And for y, we can again start from the origin and write in parametric form every 2 units up. Do you understand? That's what we mean by t here, 2 units up. So in a way, we could write this as x equals to t and y equals to 2t. Now in all these equations, t is a parameter and it belongs to a set of real numbers. So we'll say every t here in this set of equations belongs to a set of real numbers. It's kind of important to emphasize on that. Only then we can map each and every point on the line. So we get our parametric equation, right? It's kind of interesting because we've taken, and this line goes through origin, okay? Scalar equation of line L3. Now L3 is a vertical line. The scalar equation normally is in the form of ax plus by plus c equals to 0. Now here, if you see what is a and b are the normals to the line, right? So what is the normal vector here? If we have a vertical line, then the normal is along the x-axis. So this is my normal vector. That means it is 1, 0, right? 1, 0. That makes a as 1 and b as 0. So I'll write 1 times x plus 0 times y plus c, which I don't know, but I can select a point on this and then figure out, right? So what do I have here? I do have a point. Let's say this particular point is x value is 3 for us, right? So at this point x is 3 for us. Then what should be the value of c so that we get that point 3 in this equation? So to get 3, c should be -3. Do you understand? Or you can say the point 3, 0 is on the line. In that case, if I place 3 for x, then what will I get? So I'll get 3 plus 0 plus c equals to 0. That means c equals to minus 3. And now I can write down the equation of my line in scalar form or Cartesian form. It is x, since a is 1, y is 0, therefore, b is 0, therefore the center term is missing, and for c it is minus 3. Minus 3 equals to 0. So that is the equation of this particular line, right? X minus 3 equals to 0. I hope it reminds you of two-dimension equation x equals to 3. It's the same thing, okay? So that is how we are going to write these lines in the form of different equations. I hope that gives you good understanding of representing lines in R2 with the help of different forms of equations. Thank you and all the best.